Hi, welcome to video 7.1c, area between two curves, but this time in terms of y. So we talked about a little bit about that at the end of the last video. If it's in terms of x, it'll be top minus bottom. But if it's in terms of y, it'll be rightmost minus leftmost. So here's a perfect example. The function they're giving you is g of y equals y squared minus 1, which is x equals y squared minus 1. So right away, it's in terms of y. Chances are, if the function is given to you in terms of y, your best bet is to leave it in terms of y. So it's bordered by that function, the y-axis instead of the x-axis, and two horizontal lines, y equals a half and y equals a quarter, instead of two vertical lines. So if you draw the picture, this is x equals y squared minus 1. You should know that x equals y squared would look like this, right? Okay, that would be x equals y squared. And then what happens is you're subtracting 1, but keep in mind it's x equals now. So when you subtract 1, you're actually going to move to the left one, because it's the x that's getting 1 smaller than it was, okay? So that's why it's over here at negative 1, 0. So we have our curve, we have our black curve, we have our blue axis, and then we have these two green horizontal lines. So the only region bordered by all of those is this little shaded region here. Now remember, we're not doing top minus bottom, we're doing right minus left. So it'll be the integral from the bottom border, which is the y equals a quarter, to the top border, which is y equals a half, of the rightmost curve. Now in this case, the rightmost curve is the y-axis, which is the line x equals 0, minus the leftmost part, the left border, and the left border is our actual equation, which is x equals y squared minus y, and of course that's going to be dy. Okay, so then you could actually just rewrite this as 1 minus y squared, and then you can take it from there. Alright, so here's another one, number 32. They give you f of y is y times 2 minus y, g of y is negative y. So the first thing is you're going to need to graph them, you're going to need to find their points of intersection. So this really means x equals y times 2 minus y. In its factored form, makes it easier to find the intercepts. If I replace x by 0, then y is either 0 or 2. So I have 0, 0, and I have 0, 2. Those are my y-intercepts for this green parabola. Now, as far as actually graphing it perfectly, you should know if you expand it, you get 2y minus y squared. The minus y squared is why it opens up to the left. And as far as the vertex goes, because it's x in terms of y, the y component of the vertex is negative b over 2a, where your a is your coefficient of your quadratic coefficient, b is your linear coefficient. So it will turn out that the vertex is at 1, 1. Okay? So here's our green curve. The red curve is not really a curve, it's the line x equals negative y, which is the same thing as the line y equals negative x, so that is a line through the origin. You then need to find out where they intersect one another. So you have x equals y times 2 minus y, and here you have x equals negative y. Set those equal to each other, solve, and you'll find out that the two curves intersect at the point 0, 0, and at the point negative 3, 3. I get 0 for y and 3 for y. Plug those in to here, for example, and negative 0, 0, and negative 3 is negative 3. Okay, so here's our picture. Now what happens is, in terms of y, most likely it's going to make sense. Let me show you. I think I'll use this, but let me make it kind of thick so you can see what I'm talking about. Okay, so if I take this as my little rectangular strip, what I'm saying is, no matter where I place this, now I can make it a little bit smaller. How do I do that? So if I take this little rectangular strip, you can see here, the rightmost is the green curve, the leftmost is the red line. Same thing, if I make it a little bit bigger. Okay, so the right border is the green curve, the left border is the red curve. Same thing down here, same thing all the way across. So it makes sense to do these little horizontal strips, which means everything's in terms of y, because the skinny part of that rectangular strip is vertical, which is your dy. Okay? So, it's going to be the integral from the bottom border to the top border. You can visually see that the shaded region, the lowest it goes, is a height of y equals 0. The highest point of this shaded region is where y equals 3. The rightmost is the green curve, which is x equals y times 2 minus y, and then minus the left border is the red line, which is the line x equals negative y, and that's in terms of y. So, we go from there. Okay, 37 through 46, use the TI to graph the region bounded by the graphs of the equations, find the area of the region, set up the necessary integrals. Now, they say evaluate by hand. I would use the calculator. I would also use the calculator to find any points of intersection. Use the TI to evaluate the integral to verify the results. So, pause here for a second. Okay, so if you look at 37 through 46 in the textbook, okay, so use the graphing utility to graph the region, and that's because these are cubics. I mean, you could graph this parabola. These are power 4. I mean, they would be, you know, and when you get to this one, forget it. You're going to be able to do this one by hand. So you're going to use the graphing utility to graph the function. Then you're going to find the area of the region, which just means you've got to come up with the integral from what to what. And then you're supposed to integrate that by hand, but feel free to use your calculator to do that. Okay? Numbers 47 through 50. Sketch the region bounded by the graphs of the function and find the area. Now, these you should be able to do by hand. There's no calculator symbol here. You should know how to graph y equals cosine x, y equals 2 minus cosine x, etc. These are pretty straightforward. 50 is not very straightforward, okay? This is just a line, an ugly slope, but it's just a line. This is not very straightforward. This is over here. So it's basically sketch the region and decide who's on top, who's on the bottom. 53 to 56, same thing, but these have to have trig in them. Again, you would need a calculator here to graph these. These are very ugly functions to graph by hand, but it's telling you to do that. Okay, and then finally 57 through 60. What happens here is, again, graph it, explain why the area of the region is difficult to find by hand. Well, that's because it's going to be really hard to integrate these weird, bizarre things. And then you're going to use your calculator to integrate them instead. Okay, if you look at page 455, which is probably not here, is it? Let's just see where we are. Ah, it is here. Okay, so page 455, numbers 61 through 64. Okay, 61 through 64. Find the accumulation function f, then evaluate f at each value of the independent variable and show the area given by each function, each value of f, okay? Now, I mean, really what they're giving you f of x equals, you'll notice the x is up here. And then they ask you what's f of 0. Well, I guess f of 0 is the integral from 0 to 0, which makes it 0 because there's no area. F of 2 means you'll replace the x by 2. You'll find the integral from 0 to 2. So let's look at number 62. 62, they give you f of x is the integral from 0 to x of a half t squared plus 2 dt. They want you to find f of 0. They want you to find f of 4, etc. Okay? So what they want you to do here is actually evaluate this. So you'll integrate, you'll get a half t cubed over 3 plus 2t, evaluated from 0 to x. Simplify that a little bit, plug in the x, plug in the 0, so you finally find what f of x is equal to. And then they ask you to figure out what's f of 0. You could plug it into here, but of course you could have just noticed it's 0 to 0. Now, the function itself, 1 half t squared plus 2, is a parabola turning out. It's very fat, relaxed parabola, and it got moved up too, so it looks like that. So here, of course, there's no area because there's no region. The left and right borders are the same. F of 4, remember that f of x is the integral from 0 to x, so f of 4 becomes the integral from 0 to 4. Now, you've got this function. You can figure out the numerical value, but they also want you to graph it. So here's our graph between 0 and 4 in the x-axis, and that number represents the area. 73 through 76, set up and evaluate the definite integral because the area of region bounded by the graph of the function and the tangent line to the graph at that point. So number 74, the function is y equals x cubed minus 2x, and you're going to have to find the equation of the tangent line to that function at that point of tangency. So you'll need the slope, which is the derivative at x equals negative 1. Derivative of this is 3x squared minus 2. Replace x by negative 1. Your slope is 1. The equation of the tangent line is y minus 1 equals the slope 1 times x minus negative 1, which becomes y equals x plus 2, which is this line right here. Now let's find out where they intersect. So you have your y equals x cubed minus 2x and your y equals x plus 2, set them equal to each other. And you will find out, and by the way, this is hard to do by hand. It's a cubic. You need to do possible rational zeros and trial and error and synthetic division. Use the calculator. You'll find out that they intersect at negative 1 and at 2. Y coordinates are easy. Just plug them into the easy equation, which is the line. Okay, so as it turns out, the line is above. Now, as far as the graph of the actual function itself, I kind of did it up. Let's pretend you didn't have a calculator. If you factor the x out of here, you'll be able to find the x-intercepts, which are at 0 and plus or minus root 2, which are these ones right here. And you could test it, and it'll be below and then above and then below and then above. Or you could just use your calculator for that. Point is, the line's always on the top, and the green curve is always on the bottom. So the integral from negative 1 to 2, which is where they intersect, which is where you have a closed region, of the top, which is the line, minus the bottom, which is the curve. And again, I use the calculator.